All right, everyone. In order to do this assignment, one of the things that you guys need to remember back from when you guys were doing exponents is that when you're multiplying, say you have this, you add your exponents. That becomes x to the 8th. Now, with that idea, you can also break these apart as long as they add up to 8. So you could have x to the 7th times x to the 1st, or you could have x to the 6th times x to the 2nd, and so on. X to the, let's go, it was 8, how about 4 and 4? Sorry, sometimes the software closes the 4, it makes it look like a 9. Whoa, big one. Okay, I apologize for not making allowances for it closing it. You could also break it into multiple pieces. You could have x squared times x squared times x squared times x squared, as long as all the exponents add up to 8. Or x cubed times x cubed times x squared. As long as they add up to 8, you could break it apart into that number of pieces. Okay, so why do you need that? Well, that's what's going to happen here. Okay, when a power matches a root, everything will come out. Say for this example, the power and the root match, so your answer is x. This isn't big enough, so nothing comes out. It stays put. You could also write that back as the answer. Okay? This one, that's why I was talking about this over here, is if you need to, you can start to think of that as x squared times x to the 1st. The power matches the root, so this piece comes out, and that piece has to stay behind. This one, if it helps you to think of it as x squared times x squared, both the powers match, so this one pops out as x, and this one also pops out as x, so your answer is x squared. Now, after a while, writing it like this starts to be a bit of a drag, and I can show you a faster way to do it. This would be x squared, x to the 1st. They add up to 5. The root is 2. That's why I wrote it like this. Because see, like this one over here, I'd want to write everything with powers of 3 that add up to 5. So this one I'd write x cubed times x squared. Okay? Because I want the power to match the root. I want the powers to match the root whenever possible, as long as this adds up to 5, because that was the exponent there. This one's going to pop out, this one's going to pop out, so you get x squared square roots of x. This one you'd get x cube roots of x squared. This exponent isn't big enough to come out. Okay? Let's see. So this one, x squared, x squared, x squared. That pops out as x, that pops out as x, that pops out as x, so your answer is x cubed. Now there's a faster way to do it. Like I said, 2 divides into 6 3 times. 2 divides into 5 twice with the remainder of 1. The remainder goes back inside. 2 goes into 4 twice. 2 goes into 3 once with the remainder of 1. Okay, so let's try it fresh. 2 goes into 7 3 times with the remainder of 1. So that's the exponent on what stays inside. Let's see, are there more here? Yep. 2 goes into 8 4 times, so your answer is x to the 4th. There's no remainder, so there's nothing left in the root. We can try that idea over here. The power matches the root, so it's just going to pop out as x. 3 goes into 4 once with a remainder of 1. Do you have to put the 1? No, I'm just doing it there to illustrate the point. 3 goes into 5 once with the remainder of 2. 3 goes into 6 twice. Come on. 3 goes into 7 twice with 1 left over. 3 goes into 8 twice with 2 left over. So it would be x squared cube roots of x squared. X. Why is it so jumpy? Good grief. Come on. Okay. Power matches the roots. That pops out as x. 4 goes into 5 once with 1 left over. And again, when it's a 1 for either exponent, you don't need to write it. I was just doing that to illustrate the point. 4 goes into 6 once with 2 left over. 4 goes into 7 3 times, or sorry, once, woo, with the remainder of 3. 4 goes into 8 twice, so x squared. All right. So what is it going to look like in your problems? Well, you're going to have larger ones like this. 4 goes into 4 once, so you just get W. 4 goes into 8 twice. 4 goes into 4 once. 4 goes into 8 twice. Into 5 once with 1 left over. 4 goes into 4 once. Into 9 twice with 1 left over. And 4 goes into 14 3 times with 2 left over. So that would be your answer. Now these, I'm going to work with you guys a little bit more on the next page to figure that out. You're going to prime factor 24. These prime numbers are 2, 3, oops, I almost wrote 4, 5, 7, 11, 13, and so on. You start dividing the smallest prime number possible into it. 2 goes into 24 12 times. Stick with that number until you can't use it anymore. This is 24 prime factored. 2 times 2 times 2 times 3, or 2 cubed times 3 to the first. So if I rewrite this, square root 2 cubed times 3 times x to the 6th times y to the 7th, the root is 2. 2 goes into 3 once with 1 left over. I can't divide 2 into 1, so that 3 has to stay put. 2 goes into 6 3 times. 2 goes into 7 3 times with 1 left over. So 2x cubed y cubed, the cube root of 6y would be your answer. Okay. To practice this stuff a little more, I've got this next sheet here. I want you to prime, well, we just did 24, but now we're doing it square roots, cube roots, and fourth roots. If you remember from what we just did, 24 was 2 cubed times 3 to the first. So when you're doing it with a square root, 2 cubed times 3 to the first, 2 goes into 3 once with 1 left over, and 2 can't go into 1, so it has to stay put. So 2 square roots of 6 would be your answer. Now a cube root of 24, cube root of 24, 2 cubed times 3 to the first, 3 goes into 3 once. This exponent isn't big enough to do anything with, so it has to stay put. So it's 2 cube roots of 3. Fourth roots of 24. None of the exponents are big enough, so it stays the fourth root of 24. Nothing will come out of it. Right? 32. Got to prime factor it. So 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. 1, 2, 3, 4, 5. So it's 2 to the 5th. So square root of 2 to the 5th. 2 goes into 5 twice with 1 left over. Or you could write 4 square roots of 2, whichever way you want to write it. Cube root of 2 to the 5th. 3 goes into 5 once with 2 left over. So you can leave it there, or you go 2 cube roots 4. Two goes into 5 once with 1 left over. Okay, let's scoot down to 54. Let's move this along. So 54, go 2, 27. 2 won't go in there anymore. So I go into 3. So it's 2 times 3 cubed is 54. So you're square rooting 2 times 3 cubed. 2 won't come out, so I know that's going to stay. 2 goes into 3 once, with 1 left over. So it's 3 cube roots of 6. Cube root, 2 times 3 cubed. 2 has to stay. 3 goes into 3 once, so it's 3 cube roots of 2. And the fourth roots, none of the exponents are big enough, so it all has to stay. So you can either leave it there or just write the fourth root of 54, and that's good. Okay? Large numbers, I guess I'll do it. 2 and 81, 3 and 27, 3 and 9, sorry, I'm kind of running off the page, 3 and 3, 1, 2, 3, 4, so it's 2 times 3 to the 4th is 162. 2 times 3 to the 4th. Square rooting, this 2 can't come out, but 2 goes into 4 twice, or 9 squared roots of 2, whichever way you want to write it. Cube root, 2 times 3 to the 4th. 2 won't come out. 3 goes into 4 once, with 1 left over, so 3 cube roots of 6. Fourth root of 2 times 3 to the 4th. 4 goes into 4 once, so 3 fourth roots of 2 would be your final answer. Okay? And then your homework assignment is reducing these radicals. Okay? I did this on purpose where it's the same number all the way across, so once you prime factor it, then you just have to move this all the way across. You don't have to prime factor it every single time. Once you prime factor it for here, 2, 8, 2, 4, 2, 2, then it's square root of 2 to the 4th. Cube root of 2 to the 4th. You don't have to prime factor it again. You already did. Okay? Fourth root 2 to the 4th. That's why I chose the same number inside it every time. So you only have to prime factor this column, because then you have it for all the rest. And then you have to go to simplify it. So that would be 2 squared, 2 cube roots of 2, and so on. Okay? So you do have to simplify them. All right?